Good morning, everyone. I'm Usha Bhardwaj, Assistant Professor of ECE Department. Welcome to the NGF College of Engineering and Technology. My subject name is Microwave Theory and Technique, and our topic name is microwaves. So, what is microwave? Let's discuss about microwaves. Microwaves are electromagnetic waves with wavelengths ranging from 1 millimeter to 1 meter or frequencies lies between zero point 0.3 GHz to 300 GHz. Why we use microwaves? Because they are good for transmitting information from one place to another. Because microwaves energy can penetrate or travel through light rain, snow, clouds, smoke, foggy weather, etc. It's an invisible up and down pattern of electricity and magnetism that races through the air at the speed of light, which means microwave speed is equal to the speed of light, which is 3 into 10 to the power 8 meter per second, which is very high. There are some limitations also. Microwaves can damage living cells and tissues and is harmful to the people. That's why we always notice microwave ovens, which is our in home we generally used, are surrounded by strong metal boxes that do not allow the waves to escape, which means the waves cannot come out because they can damage the human. So there are some use cases used in cell phones where they carry your voice back and forth through the air and radars. If we can see the microwaves widely used in radar systems. So here are some properties of microwaves. Microwave is an electromagnetic radiation of short wavelengths, and the other one is they can reflect by conducting surfaces just like optical waves since they travel in straight line. Because they travel in straight line and they are very high and fast in speed, so microwaves current flow through a thin outer layer of an ordinary cable we can use. So microwaves are easily attenuated within short distances and they are not reflected by the ionosphere. Ionosphere is a layer of our atmosphere, so the microwaves do not reflected by the ionosphere. So here are some microwave bands. We have some microwave bands like L, S, C, X, K, U, K, Ka. So here are some which we widely used and has explained there. Most remote sensing radar wavelengths are between 0.5 cm to 75 cm. The microwave frequencies have been arbitrarily assigned to bands identified by letter, and the most popular imaging radar includes widely used in radars, and there are some bands that is X band, which is ranges from 2.4 to 3.75 centimeter, and their range is 12.5 to 8 gigahertz, widely used in militaries and commercially for terrain surveys. Other band is C band, which is ranges from 3.75 to 7.5 centimeter, and the range is 8 to 4 gigahertz. Again, is used in many space bands. There are some S bands used in L band, which is ranges from 15 to 30 centimeters, used in CSAT and JERS-1, etc. And other one is P band, which we widely used in NASA's, which is ranges from 30 to 100 centimeter, and their frequency range is 1 to 0.3 gigahertz. So these are some most common or widely used bands. Here are some advantages and limitations. So there are advantages. They provide a increased bandwidth availability, which means we use a wide range of bandwidth with microwaves because they provide, with comparison to other bands, they provide you larger bandwidths like short waves or ultra high frequency waves, etc. So, for example, the microwaves extending from lambda is equal to 1 centimeter minus lambda, that is 10 centimeter. Lambda is wavelength, that is ranges from 30,000 megahertz to 300 megahertz. This region has a bandwidth of 27,000 megahertz, as you can see. Other one is improved directive properties. The second advantage of microwaves is their ability to use high gain directive antennas, and like any EM, electromagnetic waves can focused in a specified direction just as the focusing of light rays with lenses of reflectors. Some other applications, some other advantages and limitations are fading effect and reliability. With high frequencies they are less fading, and with low frequency their fading effect is very high. Some power requirements like transmitter receivers power requirement are pretty low at microwave frequencies compared to at shortwave bands. That's why we use widely microwave bands. Here are some applications. Microwave have a wide range of applications in modern technology, which is we can see here, that is telecommunication, radars, telecommunications like intercontinental telephone and TV, space communications, Earth to space and space to Earth, that is up to down and down to uplink, telemetry communication links for railways, etc. Some radar systems we can track any aircraft or any missile with the microwave frequencies. So that's why we use in radar systems widely, that is burglar alarms, garage doors openers, police speed detectors, etc. There are some applications of microwaves. And other one is commercial and industrial applications. As we use, microwaves are widely used nowadays industrial and some commercial point of views also. So there are microwave ovens we use commercially, drying machines, food process industry we widely used the microwaves, rubber industry, mining, public works, breaking rocks, tunnel boring, etc., drying inks or biomedical applications. There are some specific applications in biomedical also where we use microwaves. So some other applications like identifying objects or personnel by non-contact method like radars or etc. Another one is light generated charge carriers in a microwave semiconductor make it possible to create a whole new world of microwave devices, fast jitter free switches, phase shifters, HF generators, etc. There are some civil applications also. Telecommunications as we discussed earlier, radars as we discussed earlier. Other one is navigation, which is GPS satellites uses microwave signals for positioning. Nowadays we share our locations, so here we use. And heating, microwave ovens like we already discussed in industrial drying, currying materials and plasma heating in fusion researches also. Here are some military applications like radar systems, missile guidance, as we discussed, used in tracking and directing missiles. Nowadays, if we use it in wars, mostly we use why? Because it is used in tracking and directing missiles. We can track any coming missile and we can track and we can direct our missiles also. Some electronic warfare, EW, jamming enemy signals and detecting threats. We can jam the enemy signals uh, coming to our way and we can detect the threats in advance. So directed energy weapons like stealth technology, etc., aircraft designed to absorb or deflect radar, microwaves to evade detection. So these are some use cases of and applications of radars where we use it. So thank you for the today. That's all for the today. Thank you.